Okay, so for today's lesson, we're looking at multiplying algebraic fractions. And this is part 2 of the video. You will find this video to be a little more interesting than the one before because we're going to be looking at much more complex questions than the ones that we've looked at in part 1. Okay, so first thing to remember is that whenever you're multiplying your fractions, algebraic fractions, remember the same rule applies. Numerator times numerator and denominator times denominator. It's very important for you to remember these things. Also, especially when possible, when multiplying algebraic fractions, please factor where possible. And you're gonna see exactly what I mean with these questions. So please factor where possible. Um, so and also for those who are struggling or still need additional assistance, please practice a factorization because it makes multiplying your fractions much easier, especially when you're simplifying these algebraic fractions. Alright, so now we'll be looking at our first example. And our first example, we have 5x squared minus 20 over 3x multiplied by 9x, so that's 9x over 2, x minus 2. So we have two fractions that we're multiplying right now. And the first thing that we need to do is to see all of the factors or all of the terms that we can actually just factorize. Now look at the numerator for the first fraction. I'm gonna highlight it so you can see. Look at the first. So right here, look at the numerator of that first fraction right there. We have 5x squared minus 20. Of course, we can factorize this by selecting or using its highest common factor. So if we are using the highest common factor to factor out the numerator for the first fraction right there, which is 5x squared minus 20, what's the highest common factor for both 5x squared and 20? It is just what? 5. So I'm going to write it below right here. So 5 bracket. So if we take 5, from the first term right here, 5x squared, we will be left with x raised to the power of 2, or x squared, minus, look at the second term right here, it's 20. So if we take 5 from 20, meaning 5 divided by 20, we'll be left with just 4. Alright, all over 3x times 9x over x minus 2. Now, the first thing that you'd want to do is factor in a way where you can see clearly terms on the bottom and on the top that are similar. Now if you look right here, let me see if I can highlight it. If you look inside this bracket right here, x squared minus 4, x squared minus 4. Now looking at this bracket right here, even though we have factorized already, the 5 from the 5x, squared over 20, even though we have done that so far. If you look at the x squared minus 4, we can actually factorize again, because this is actually the difference of two squareds. So if you look at x squared, we have the first squared term, and if you look at 4, that is also a squared number, so we can factorize that again. So you will have, let me change it to the pen, so we'll have 5, and we'll have our, now when if we are factorizing the x squared minus 4, we'll end up, what's the square root of x squared? That will just be a simple x plus, so whenever we are factorizing difference of squares, you know that we're gonna have plus and minus, so plus 2. Why? Because the square root of 4 is 2. So plus and minus, so we're gonna have our x minus 2. So we had, what we did right here was just to factor this term right here, what it was in the bracket. So we had a x squared minus 2, so we just factor it because using difference of 2 squared. So so we have that over x, sorry, 3x, and this fraction is multiplying our 9x over x minus 2. So far the only thing that we have done before so far was just to factorize the 5x squared minus 20. All we did was just to take 5 from the two terms, factor out the highest common factor, so we just took the 5 out. Afterwards, inside the bracket we had x squared minus 4. That's literally just the difference of two squares, so we just factorize using that, and we have our two brackets, which we have x plus 2 and our x minus 2. Now this is where the fun begins, or no, we can actually start simplifying our fraction. Now I'm gonna change the color of the marker to something differently so you can easily see what I am talking about. Now, looking at the two fractions right here, when we cancel or when we simplify, we look at the terms, or we look at the factors at the top, and terms and factors that are at the bottom of the fractions to determine whether or not we can cancel. So because we're looking multiplying these two fractions right here, if you look above, or at the numerator, right, for the first fraction we have our x minus 2. Looking below on the denominator right here, we have x minus 2, so we can cancel both of these out because they're the same. These factors are the same, so we cancel these out. So that's one factor that we cancel out. Now what I wanted to do is also to highlight this as well, because I want to see exactly what I'm talking about when I do the next the next step. Now look right here, we have a 3x and we have a 9x. Look at both of them, 3x, 9x. These are terms that can simplify, we can simplify or factor out. So what's the highest common factor between 3x and x? Now if you look right here, let's go with it quickly. We have 1x right here, so we can take 1x and 1x above right here, we can take 1x from above right there. We have 3 and we have 9. So what what number can divide both 3 and 9? That will just be 3. So we can cancel that out. And if we divide 3 into 9, that would just be, you'll just be left with what? 3. Now another way of looking at this is that just as how we factorize right here, we can just say that, okay, we factorize the 3x from right here and the 3x from above right here, to simplify. So if we take 3x from 9x, let me write it right here. If we take the 3x from 9x, because this is exactly how it would have looked if I did it right there. So I'm just showing you, another visual representation of it. If we took 3x from 9x, right, and divided it, x cancels x, and 3 divided by 9, that you'll just be left with what? 3. So that is exactly what's going on down there. So let's write out our fraction with everything that we have done so far. So this now will be equal to, so we'll have our 5, our x, in bracket we'll have our x plus 2, so our x plus 2, we cancel the x minus 2 because 1 was below. X minus 2 divided by x minus 2, that would definitely just cancel out. Over here we're multiplying by 9x. We divided the 9x by the 3x below right here, and we were just left with 3. So multiplied by 3 all over uh, we had gotten rid of all denominators, so we can put a 1 right there. So all we have to do is just simplify a bit further to make our so we can have a more refined answer. So 3, we can multiply the 3 by the 5 to get our final answer. So 3 times 5 is 15. So we have 15, and we have numbers in bracket. That would just be x plus 2. And that will be our final answer. Don't worry about the 1. You can put any number over 1. 100 is the same thing as 100 over 1. So just put it right here as a placeholder to show that, we had already eliminated the 3x. When the 3x divided the 9x right here. So 3x divided by 9x would have just left you with 3 above right here. So the 3x would have already cancelled out. The x minus 2, we cancel it out as well, because after we factorize the x squared minus 4, we had x squared plus 2 and x minus 2. So x plus 2 and x minus 2 inside the bracket. So we canceled out the factor x minus 2 by the x minus 2 below. So the both denominators were cancelled out. So that is the reason why we never had to have any denominators right here. If you wanted to, we could also distribute this. So we can have 15x, and 15 times the 2 would just leave you with 15. So 15x plus 30. So either way, this would be your final answer. Alright, so let's look at number 2. So for number 2, example 2, we have terms on the numerator and denominator that we can factorize. So let's see if we can just factorize them, quickly, and we move on from there. So let's firstly highlight the numerator for the first fraction. So for the first fraction right here, we have x squared minus 4x. First, those persons wondering, sir, we have a 4x. So is that the difference of two squares? No, this is not the difference of two squares because this is just 4x, not 4x squared. This is just 4x, not 4x squared, meaning we just have one x right here, not x raised to the power of 2. So this is not a squared term. Even though the number is a squared number, because the x is just a single x, it is not a squared number. A squared, variable or a letter. So it's a letter that, actually changed this. So it's not considered, a squared term, 4x. So let's finish our work and let's change the color. So we'll be looking at, so let's start by simplifying. So let's start by factorizing. So we have x squared minus 4x. Now all we have to do is to remove the common factor right there, the highest common factor. And the highest common factor from x squared minus 4x would just be x. So let's write it right here. So x in bracket. Now after removing the x from the two terms, we'll just be left with x divided by x squared. That will just be x minus x from 4x. That will just be left, you'll just be left with just a regular 4. And then we can write right here our numerator. For our for our denominator below the first fraction right here, let me just highlight it so you can see what I am talking about. So for the denominator right here, which is 9, 9, and we have a x squared. So x squared minus 9, that is actually a difference of two squares because 9 is a squared number. So 9 is a squared number. And if you realize we have a x raised to the power of 2 right here, x raised to the power of 2, so that is a squared, number. Sorry, that's a squared letter or a squared variable or a squared term, whichever way you prefer to call it. So let's factorize the terms below. So we should have two brackets whenever we are factorizing the difference of two squares. So your square root of x squared will just be x. There's a minus sign right here. Difference of two squares means that you have to have one with bracket with plus. What's the square root of 9? So the square root of 9, would just be 3. And we'll have the same thing inside the second bracket, but you know that you just change the sign from plus to subtract. So in one bracket you have plus, the other bracket you have minus. That's how we factorize using difference of two squares. So we have our x squared minus the 9, and square root of 9 is 3, so 3 in both brackets. Now let's look at the second fraction right here. So looking at the numerator for this fraction, we have x squared plus 9. So we can factor, if we wanted to, we can factor 3 from, you know, we can factor 3 from the two terms above for the second fraction. So in the denominator right here, the highest common factor would be 3, because 3 can go into 3x, and 3 can also go into 9. So the highest factor, in using the highest common factor, we'd have 3. In bracket, we'll have x plus 3, and for the denominator, we'll just put our 2x right back. Okay, so now that all terms are in place, now that we have all terms in place, now we can do the fun part, which is just to simplify. Now, when simplifying, if you haven't caught on as yet, whenever you simplify from the bottom, meaning that if you want to cancel out anything, if you want to cancel anything from the bottom, it should be there at the top as well. It doesn't matter which direction. So anything you cancel from the bottom, it must be at the top to cancel out. Alright, so let's work on this right here. So we have a x plus 3 right here. There's an x plus 3 above. We can cancel this. Yes, so I hope that you were following. Alright, now also we have a x right here and an x above right here. So because we have those 2x, we can cancel as well. 1x from here, 1x from there. So now that we have cancelled out all that we need to cancel, we just write what we have now. So let's write back our answer. So all of this, after cancelling or after simplifying, you write what you did not, cancel. So we'll have our our x minus 4 and we'll also multiply by 3, and we'll also have our x minus 3 multiplied by 2. Another way of writing this, so that would just be equal to 3 x minus 4 over 2 x minus 3. Person saying, Mr. Williams, why didn't we cancel out the x that is here below and above? No, we can't do that because the factor is x minus 3. It was different from the 2x above right there because we could easily, factor x from the 2x right here. So x was factored from the one from the x minus 4 as well. So we could cancel them, both of them. But in this case right here, the factor is x minus 3. So there's no other x minus 3. So we can't just factorize the x from each other. No, it can't work. So we have this right here, this fraction right here, and there's nothing else that we can do to simplify. So all we can do, if we want to write a little bit better, we can just distribute. So distribute, we can distribute the 3 and the 2 to each term inside the bracket, and by distributing it will change our answer. Well, it'll have the same meaning, but it will change the way our answer looks. So 3 times x will give you 3x minus 3 times negative 4 will give us negative 12 over 2 times, we distribute the 2 to both terms in the bracket, so 2 times x will give you 2x, so that's 2x, and 2 times negative 3, that will give you negative 6. So that is our answer for this question. Right here, looking at it, we have a term for the numerator that would have to factorize using the AC method. If you look at the numerator above right here, the numerator above, this these three terms right here is actually a quadratic expression, so we will have to factor using the AC method. So let's factor using the AC method right here. So if we're using the AC method, then our AC would be equal to 6 times, so this is A, this is B, this is C. So our A is 6, our C is negative 2, so 6 times negative 2 will be equal to negative 12. And our B will be equal to, you have x alone, so the number for that's actually right there is just 1. So what we have to do, find two numbers that can add together to give you B, and what can multiply together to give you our AC, which is negative 12. So the two numbers, let me change the color of the pen. So the two numbers that can add together to give you 1 and will multiply together to give you negative 12, that would just be negative 3. So negative 3 and 4, because negative 3 plus 4, that will give you 1, and negative 3 times 4, that will give you uh, negative 12. So that will give you a negative 12. So let's quickly write right here. Let me just quickly put it right here, or we'll factor. So if we have our 6x squared, right where you have your plus x right here, we just put the first term. I prefer to put the negative 3x, so negative 3x plus 4x need a little bit of space right here, so let me quickly just erase. Let me quickly erase. So as I was saying, so let's write it using a different pen. So we have our 6x plus, sorry, minus, because I'm gonna use a 3 right here. So 3, you replace the x right here. You replace the x right here with 3x, and we'll have our plus 4x minus 2. So factoring that out right here by the first two terms, we can get a 3x out of it. So if we take a 3x out of it, the first two terms, then we'll be left with inside the bracket 2x minus 1, and over the second bracket right here, the next two terms, we have 4x, so 4x minus 2. So 4x minus 2, what's the highest common factor between 4x minus 2? That would just be 2. So plus 2 plus 2. So if you take a 2 out of the 4x minus 2, you'll be left with 2 into 2 goes 2 times, so 2x, and 2 divided by 2, that will just leave you with negative 1. So in all, we should have two brackets. So one bracket will have our x, or 3x, everything outside of the bracket, so 3x plus 2. I did not know I would have, teach or taught the AC method in this video, but if you actually learn the AC method in this video, then good for you. All right, and we have what is inside both of the brackets. Normally it should be the same term, so x minus 2x minus 1, and we'll have our 2x minus 1 again. 2x minus 1. So now that we have factorized, our quadratic expression right here using the AC method to get the two terms, let's quickly, just write out the factors so we can quickly solve this or simplify these two fractions so we can just have our final answer. So let's write the factors right here. So we have 3x plus 2, so that's one bracket, should have another, and the other bracket is 2x, so 2x minus 1, that's the other bracket, all over. Looking right here, we have a 4x squared minus 1. Now for those who do not know, 1 is actually a square number because 1 times 1 is equal to 1. We have a 4, and 4 is a square number. We have a x raised to the power of 2. So this entire term right here, let me highlight it for you. This entire term right here, 4x squared, this is a squared term. This is also a square number. So right here, that's just difference of two squares. So let's quickly write the factor the difference of two squares. So the square root of 4x squared is just 2x. So 2x Remember, with difference of 2 squared, we have a plus and a subtract in each bracket. So the square root of 1 is just 1. The other bracket, 2x again. In this bracket right here, you have the subtraction sign instead of the addition sign. So subtract. So 2x minus 1 multiplied by multiplied by 2x minus 1 over 3x plus 2. Alright, so now that we have done that, and now that we have done all the factorization, we can do the fun part, which is just to simplify. Now simplify, as I said before, you simplify all of what you see at the bottom with what you see at the top. So if you realize, if we look right here, we have a 2x minus 1 and we have a 2x minus 1 up right here, so we can cancel that. And if you look as well, is there any other? Yes, we have a 3x plus 2 and we have a 3x plus 2 right here, so we can cancel. Let me change the color so we can cancel, and let me circle what I'm talking about. If you look right here, there is a 3x plus 2 and there's a 3x plus 2 right here, so we can cancel both of these factors. So when you cancel these factors, we're left with just, let me write the answer. So we're left with just 2x minus 1 over 2x plus 1. So that is our final answer. Person's wondering, sir, but I see a 2x above and a 2x below. Remember, these are, we have to look at it as what we see right here. The term is 2x minus 1. This right here is 2x plus 1. We don't, there's nothing that we can factor between the two terms right here. We can't factor out anything to simplify. So we have our final answer right here.